So now that we're dealing with questions involving free fall, this is an object that's being dropped or thrown, and the only acceleration that it experiences is acceleration due to gravity. We will always be using 9.8 meters per second squared down for gravity's acceleration. Just we'll always go with 2 sig figs on that one. So a seagull drops a shellfish from a height of 12.5 meters. That would be our displacement. And looking at direction, the seagull drops it, so it is traveling 12.5 meters, down to collect the shell. Determine the speed of the shellfish at impact. That would be at the end of this, so that would be a VF that we are trying to find. Now that is clearly not enough information to be able to determine this, so we need to read a little bit more into the question. Since the seagull is dropping the fish, it has acceleration due to gravity. And with gravity, we're not going to call it A anymore, we're going to call it G because it's a very specific acceleration. That would be 9.8 meters per second squared down. And since the seagull is dropping the shellfish, we can safely assume that it's not flinging the shellfish up and then letting it drop. It's just opening its beak and letting it fall out. So in that case, that would mean our VI would be 0. Easiest equation to use here would be VF squared equal VI squared plus 2A delta D. Substituting in what we know, VF we don't, VI is 0, A 9.8, D 12.5. Zero squared is 0, and 2 times 9.8 times 12.5 is 245. Taking the square root of both sides and going to 2 sig figs. Oh, that should be VF squared. I am sorry. Square root of both sides, 2 sig figs, we would get 16 meters per second. And the speed of this shellfish is most definitely down.